Hello, students. This is Saxon Algebra 2, Lesson 49b, which they have called Transversals, and I prefer to call Transversals and Right-Angle Trigonometry. So let's go ahead and review our trigonometry. We use so katoa. So katoa is our mnemonic for remembering how to calculate the sine, the cosine, and the tangent, which are the first three trigonometric functions that you learn. And we learned their definitions based on a right triangle. And so the sine is equal to the opposite over the hypotenuse. The cosine is equal to the adjacent side divided by the hypotenuse. And the tangent is equal to the opposite side divided by the adjacent side. Now, you also have learned that if you have a value for the sine, but you don't know the value of the angle, that you can use the value of the sine to find the angle. And those are abbreviated sine to the minus 1. So in your calculator, if you put in sine to the minus 1 and your value of the opposite over the hypotenuse, your calculator is going to tell you what angle that is. Make sure you're in degrees and not radians. It would tell you the angle in radians, but it wouldn't be very meaningful to you for the things we're doing. And similarly, the cosine, you just put the cosine to the minus 1 and the value of the adjacent side divided by the hypotenuse, and it'll tell you the angle that goes with, and the tangent to the minus 1. These on our calculators are usually in small yellow print above the sine, cosine, tangent button, and there's a yellow button that gets you that function, that second function. So you press your yellow button and you press your sine, or in this case, you press your tangent, you get your tangent to the minus 1. You put in your opposite value divided by your adjacent value, and your calculator will tell you the angle. Now, we don't need this information for the problems in lesson 49b, but it's always good to review. So let's talk about transversals now. One thing to remember about transversals is generally, this is a term used for a line that crosses two or more parallel lines. And we've learned that all the small angles are equal when you have a transversal. So these are equal because of the transversal, and these are also equal because they're vertical angles. And all the big angles, or large angles as your book says, these are equal because of the transversal, and these are equal because they are vertical angles. And there's one more thing about transversals that I want to remind you of, or maybe point out, is that the transversal will divide each parallel line into a pair of straight angles. There's a pair. Straight angles are supplementary angles, so these two angles equal 180 degrees. These two angles equal 180 degrees. These two angles equal 180 degrees. And these two angles equal 180 degrees. Now, I meant to put my arrows on here just in case these weren't perfectly parallel. I didn't, measure carefully. But remember that when we use notation, you put that arrow on two lines, even if they look like this, you put the arrows on there, they're parallel lines. All right. I think that with that under your belt, you should be able to do the practice problem immediately, but I want to just go ahead and go through the example 1 for your listening pleasure. Example 1 gives you this diagram, and they ask you to find A and B. Now, one of the things that you want to do is recognize that this diagram is actually a combination And often Saxon likes to use combinations because combinations exist in the real world. But if you just cover up that, you've got two parallel lines with a transversal. And they tell you that this angle is 153 degrees. So this angle is also 153 degrees. And angle P here forms a supplementary angle with 150 degrees. So angle P is going to equal 180 degrees minus 153 degrees, which is going to be, it's going to give you a 7 there. And so it's going to be 27 degrees. So right there, we've got angle P. And now we could cover up the rest of it and just have our right triangle. It's hard for me to do that with this card. Well, I kind of did it there with the card. And now this is the part of the diagram we need to find A and B. So we have angle P is 27 degrees. And we don't even really need to know what the other angle is, but it's going to be the complementary angle because P plus this unknown angle are going to equal 90 degrees. But we can set up the sine of 27 degrees is going to be equal to B, the opposite, divided by the hypotenuse, and they've given us the value of the hypotenuse. Remember, the hypotenuse is always opposite the right angle, B over 7. And so 7 times the sine of 27 degrees is going to give us B. Then if we do the cosine of 27 degrees, the adjacent side to this angle is A. It's going to give us A over 7. So 7 times the sine of 20, I'm sorry, one of my mistakes. 7 times the cosine of 27 degrees is going to give us A. You can do that on your calculator. And presto changeo, you're done. I think that angle Z was only included in this diagram so that you could find, see clearly that that's a straight angle. And so angle Z is also 27 degrees. And then you've got, remember, you've got your transversal going on here. So here's a small angle and here's another small angle. And so they're going to be equal. I will leave you to find A and B with your calculator or by looking in the book because they have the answers, because this is the example. And I hope this helped you to master this part of the lesson, and I'll see you next time.